The last part of this lesson is on exponential equations. So we're going to take all of the properties that we have learned and we're going to use them to solve exponential equations. An exponential equation is one in which a variable occurs in the exponent. For example, 5 to the power of 2x plus 3 equals 5 to the power of 3x minus 1. When both sides of the equation have the same base, the exponents on either side are equal by the property. But this is the formula for the property. So you have b to the power of m equals b to the power of n. That means that m is equal to n. Once we have that and the bases are the same, we can omit the bases, write the equation using just the expressions for the exponents. 2x plus 3 equals 3x minus 1, and then solve for x. So let's put this into practice. Make sure you're writing these down. Okay, here we go. So the bases are the same. So we just need to write down the exponential expressions or equation. I'm thinking of both. And solve it. So we subtract 2x on both sides. We get 3 equals x minus 1. We add 1 to each side, and x equals 4. Now, that doesn't mean that the exponent is 4 for both 5s. This means we need to plug it in and see what the exponent actually is. So 2 times 4, doing this one, is 8, plus 3 is 11. So the exponent on this side is 11. Let's check this one. 3 times 4 is 12, minus 1 is 11. And this is a way for us to check our answer because we knew that the exponent for both 5s was supposed to be the same. Let's try this side. Again, we have the same base numbers, so we can omit those and just write our equation for our exponents. Solve it. A equals 2. This means that on this side, the exponent is negative 4 because we have negative 2 times a, which is 2. And on this side, we have 2 minus 6, which is negative 4. So this checks out. Now, there's going to be times where the base numbers are not the same. So we're going to have to do things a little bit differently to solve those ones. So let's look at these examples when the bases are not the same. They will have something in common. We should be able to write the bases the same because they should be like multiples of each other in exponential ways. So what I'm saying is we can't rewrite 8 with a base of 4 because 4 to the power of 1 is 4. 4 to the power of 2 is 16. We've already passed up 8. We've skipped it. But what number do they share in common that can be written with an exponent? Well, we can write 4 as 2 squared, and we can write 8 as 2 cubed. So we're going to rewrite these with the same base. So 4 we're going to show as 2 squared, put it in parentheses because that's just showing the 4. And then you have the exponent x minus 1. That equals 2 cubed. That represents the 8, the base, and the exponent is 3x plus 4. Now that we have the same base numbers, we can perform the power of power property to find out what the exponent expression is. We need to distribute the 2 times the x minus 1. So we're going to get 2x minus 2. We're just focusing now on these exponent pieces, okay? Then we distribute here, we get 9x plus 12. Now we can solve for x. We'll subtract 2x from both sides. And then we'll subtract 12 on both sides. So x equals -2. Remember, we need to substitute this back into the top to check it. So up here, -2 minus 1 is -3. 3 times -2 is -6. Plus 4 is -2. And it's okay that they're not the same because our original base numbers were not the same. So what are we looking at? Well, we're looking at 4 to the power of -3 being equal to 8 to the power of -2. So let's check that. This would mean that you have 1 over 4 to the power of 3. 4 times 4 is 16. 16 times 4 is 64. 8 to the power of -2 is 1 over 8 squared, and 8 squared is 64. So they check out. On the right side, you have 1/16. Remember that we can write this. This is actually 4 to the power of -2. But again, we're stuck with a base of 4 and a base of 8. So we want to use a 2 again, instead of trying to write it in terms of a 4, because it won't be possible to make 8 that way. So we can say that this 1 over 16 is 2 to the power of, what would that be? 4, 2 to the power of 4. So this is 2 to the power of -4, this one over here. And this is 2 to the power of 3. We have to put that in parentheses because we have a different exponent out here. We have to distribute to get rid of these parentheses first. So keep this side the same and distribute. You get 6x plus 6. Now our bases are the same, and we can just solve for x in our exponential equation. We are going to subtract 6 on both sides. (6x) is equal to -10. Divide both sides by 6. X equals, this is reduces to 5/3, -5/3. Okay, so that's how, when the bases are not the same, you need to, sometimes you can just use one base and convert it to the other. But in these cases, we needed to think outside of the box and come up with a number that was not shown. It wasn't a 4, it wasn't an 8. We actually needed to use a 2 to represent the 4 and the 8.